Hello, my name is Robert Terry, and I'm the general manager of the Master Flux business unit inside Tecumseh. A lot of people recognize Tecumseh as a manufacturer of compressors in commercial refrigeration, but the Master Flux business unit is focused primarily on mobile transport refrigeration applications. So I'm going to share with you today some information about our compressor solutions that are really intended for transport refrigeration. All electric, all direct DC, variable speed, variable capacity compressors. So inside Master Flux, as it relates to transport refrigeration, we really focus in three areas, three applications. Last mile transport refrigeration like vans, light trucks, three-wheelers, some autonomous vehicles, things like that. What we call refrigerated box or transport containers, food, pharma. Everybody has seen like COVID vaccines on aircraft, active control containers, things of that nature. And then specialized refrigeration systems, kind of a catch-all category for medical process chillers and things of that nature. So when you think of Master Flux compressors, think of direct DC variable speed compressors. Inside Master Flux, we have a range of compressors from what we call the Mesa, which is a miniature rotary compressor, all the way up through our newest product called the Alpine compressor. And I'll share some information about each one of these platforms, but also inside our business, we also develop the controllers or inverters. We say controllers because they're DC to DC. And inside our business, we develop the DC controllers as well to go with the compressors. So the controllers really provide the on-off control, the variable speed control, protection diagnostics for the compressor, and ultimately, in part, the system. We also focus on using our compressors inside our own systems. We develop transport refrigeration units for vans and light trucks. These can be roof-mounted, nose-mounted units that provide DC battery-powered refrigeration for food, pharma, medical products. And I won't focus on it in this presentation, but we also develop compressors for high-temp air conditioning applications for EV vehicles like passenger cab cooling or battery thermal management. And again, our strategy is to use our compressors inside a whole line of battery thermal management systems, which we also produce. So I'll focus mainly on the refrigeration applications for this presentation, recognizing that we do have high temperature air conditioning and battery thermal management systems as well. So the workhorse or the legacy product inside the Master Flux product line is called the Sierra compressor. This compressor has been around since 2003, developed for Class 8 over-the-road long-haul air conditioning applications in North American market. And this compressor, we have in three displacements, 7, 11, 16 cc. They're all direct DC variable speed compressors. The interesting thing about the Sierra is we have a very wide DC voltage range. We cover applications from 12 volt, 24 volt, which is a lot of the commercial vehicle applications, 48 volt, up to now for EVs, 450 volt, 650 volt, and we're developing a product now up to 850 volt, which is typical of some coach and bus applications for EV cooling. For refrigeration, for low temperature applications, today we're focused on 404A and 452A. We do have models released now in 290, and we're continuing to develop more models for 290 and propylene in the future for low temperature applications. Again, being a rotary compressor, it's high pressure ratio compressor, so it's good for heat pump applications as well. And we use them in heat pump applications, which in the EV application space is becoming more and more important because the engine's gone, the waste heat's gone, and now you need to produce high efficiency heating. Our controllers that go with these compressors, basically IP67 enclosures, CAN bus control, and provide the speed control, the on-off control, protection, diagnostics, and interface. In low temperature, the Sierra ranges up to about 1,500 watts, I would say, in low temperature application. We have a new platform called the VHG. Think of this platform as a horizontal version of the Sierra compressor with improved efficiency, improved COP. This the current model is being released in 16 cc, and we are putting the basically the same controllers used for Sierra can be used for VHG as well. So it has the same voltage range, the same IP67 enclosure, the same CAN bus control interface. In the VHG, due to the horizontal nature of the compressor and the technicalities with lubrication, we have reduced the top end speed a little bit compared to the Sierra in the vertical configuration, which gives us a touch less capacity than in the Sierra, just because the top end's 5,500 RPM versus 6,500 RPM. Our Alpine platform is a brand new platform. It's a ground up, brand new design. We're in the development stages now, and we have this is a 36 cc compressor designed specifically for transport refrigeration, electrified transport refrigeration. And here, this compressor gives really good COP and a high efficiency, up to nearly 5,000 watts of cooling of refrigeration capacity in this compressor. Very compact design. The Mesa compressor platform is a micro miniature rotary compressor. It's really intended for high temperature applications. It can work in evaporating temperatures down to about -10, but it's really intended for positive temperature applications. It's very small, 1.4 cc and 2 cc offers with a good performance in terms of COP and capacity. This compressor, actually all these compressors, Sierra, VHG, Alpine, and the Mesa are on display in our stand here in Hall 5. So I'd like to talk to you a little bit about our system side now. We make the compressors, we make the controllers, but really we're focused on making systems. In this presentation, I'm talking mainly about refrigeration. We say EMRU, Electrified Mobile Refrigeration Units. It's an acronym we use. And we have a series, some platforms, I guess I would say, of micro series, slim series, standard series, and then our low profile rooftop or nose mount for transport, last mile delivery in a delivery vehicle application. So here inside of our business, we take our compressors, our controllers, we make these systems. We have a platform, basically a platform, but what we will do for certain applications with certain clients is customize the controls or the form and fit of these products. We're open to do that and find this is a very valuable way to, in every application, it's about fitting, it's about fit. So we do this. Think not only transport refrigeration, but some of these systems are used in food service. Think food truck applications and food service, back bar applications, pizza prep tables, salad bar, refrigerators, things of that nature. I want to focus a little bit on the van and light truck units on the right here. This is just some specifications. We have a 6 kilowatt unit in fresh. It's about 3.5 kilowatt in frozen. So in the transport refrigeration applications, we talk a lot about fresh and frozen. Can it do both? Do you have to have a special system just for fresh food or frozen food? Our intention is to develop variable capacity systems with compressor technology that allows us to use the same system in fresh and frozen. This is not easy to do, but this is always the goal of our technology and our end customers' product applications. So here's an example of the 6 kilowatt unit using microchannel coil. This is a very low profile unit used on the roof of vehicle boxes, delivery or on the nose. Sometimes on the front of the nose, you see this with a shroud, plastic shroud over it. This is the kind of product this is. In this case, this is a condensing unit, the high side. Inside the box is obviously an evaporator coil that we work with. It's how do you say, very compact, simple design compared to a mechanical system, a belt-driven system, a direct drive, what they call direct drive systems. These are very simple systems, very easy to install. Not a lot of moving parts, frankly, and so consequently there's a benefit in terms of reliability and simplicity for installation and service. Today we're focused on, again, 452A, 404A in the North American market, and 1234YF. We are looking at actually testing propane now and propylene, which is just in some of these lower evap temperature applications can give some advantage over propane. We have a smaller version of this, 2.5 kilowatts in fresh. This is used in vans. So literally like transit vans or vans that are truly last mile delivery applications, usually on the roof, sometimes without the cover, just a chassis version mounted underneath. There's a few companies in Germany, in fact, that use this technology in an under chassis mount arrangement for a refrigerated van. Same application goals or design targets to have low profile, simple design, less complexity and more reliability. Again, just to reiterate, all direct DC. So these run directly off the battery. We don't do any DC to DC conversion or DC to AC or AC to DC conversion. So direct DC applications. And I'm going to show a couple of examples comparing this technology to a direct drive unit. And I don't know if a direct drive unit, basically an engine driven refrigeration system. So on your left, this is a kind of a typical nose mounted direct drive unit. They're bulky, they're mechanical in nature. It takes some complexity to install them, to link them to the engine. The performance of these systems, the cooling capacity, and refrigeration, performance is generally linked to the engine and the RPM of the engine and the stop and go of the engine. So an electric system eliminates all those variables. Basically, it runs on batteries. It gives the cooling capacity that you need at the time you need it. If you have a low demand application, you can run slow and conserve energy. If you're in a neighborhood or a subdivision or residential area and you're stopping a lot, opening the door a lot, here you can run the compressor faster and maintain temperature. We've seen in our testing in our labs, this is a picture of a refrigerated box for a truck, a side door mount application in our labs in North America, in Ann Arbor area. In Michigan, we've done some testing and compared some loaded and unloaded pull downs with an electric system versus direct drive system. And you can see here, just on pull down, significant advantage in pull down performance on a equivalent pull down test at 100. It says 100 F here. I should have put it in Celsius, but about half, sometimes about half the time to pull down. We've paid a lot of attention to serviceability of the unit, basically putting the refrigeration controls, refrigeration lines on one end of the unit, and the electrical interface on the other side of the unit to make the service and installation simple. So here's just some test data of our unit from the labs. The left-hand column is a no-load test, pull down and run test, and the right side is a pull down. It's a loaded 100 F test. Thank you. Pull down test, and you can see here just some actual data to support that 1.5 hour pull down 100 F loaded test. So very good performance, actually. I mean, that's the idea of a variable capacity system. Is when we have the high load, we can pull down fast. When we have a need to save energy, we can run slow. So just to wrap up, one more slide, just some of the kind of value propositions, if you will, of a electric transport refrigeration unit using the Masterflux compressor technology compared to a more traditional direct drive system. These units are smaller. Like I said, they're less complex. They're not bulky. They're not mechanical in nature. So the installation and service is easy. They're smaller and lighter weight, which is a necessity, if you will, for using these in electric vehicles. So these electric systems, doesn't matter if the van or truck has an engine or doesn't have an engine. They're running on batteries either way. So this is another benefit because some of these are going electric and the weight and size is smaller, which is better. The compressor is a hermetically sealed electric variable speed compressor. We all know what this is. Typically, in our case, rotary compressor technology, which is commonly used in transport refrigeration. But again, no clutches, no belts, no direct drive equipment, fast pull down and energy performance for use in EV applications, service friendly, and designed for serviceability and maintenance. So that's really it. Just kind of overview of the key takeaways is we develop and produce electric compressors. A long time doing this, more than 15, 16 years doing this. And this compressor technology is evolving fast, given the growth of last mile transport refrigeration and EV cooling applications. So as we move from being just a compressor supplier to a systems solution provider in these spaces, there's a lot of value in being vertically integrated to provide the same compressor inside the systems. So that's it. Thank you. Come see us at booth 332. We have a couple things there interesting. We have a bicycle with like a delivery bicycle with a refrigerated box on the back using the Sierra compressor. It's pretty cool. And we have an example of all of our compressors and the transport TRU unit there as well. So we're just in Hall 5. Thanks.